warm welcome. My name is Eike Schäffer of the Institute of Factory Automation and Production Systems, and I'm very proud to present our process-driven approach for the engineering domain in behalf of our co-author team. What is the idea behind this approach? Therefore, at first, I will give you a general idea how this approach fits in an engineering project. Then I will highlight the problems and the general solution. Based on these, we introduce the PDA architecture and especially the PDA architecture for the engineering domain. We start with a general project overview. The idea emerged within the research project Robotop, where the aim is to enable SMEs to easily automate and to get an easier access to knowledge of automation solutions. You have also to coordinate engineering processes, and therefore new ways, new possibilities were needed. We take a look at different approaches. To give you a general idea, what is the problem within engineering? Costs, according to the rule of 10, are low at the beginning. If you're doing an error within planning or development, they are small. With every phase, if you order the wrong robot, if you order the wrong components, or if you are in the assembly line of a customer and then something goes wrong, the costs increase exponentially. Therefore, it's very important to reduce errors at an early stage. Good processes are key. In general, I'm the one who is looking at the part system architecture and configuration, especially the PDA is more focused on the system architecture part and how to coordinate the microservices we are using in the background. So the general idea behind Robotop is a best practice-based adaption configuration where a customer is selecting based on some easy filter criteria a best practice and then customize this configuration. And therefore, we use different microservices, one for best practice selection, AML data conversion, simulation, configuration, and further. And these are all orchestrated within a microservice architecture. To orchestrate processes within process-driven approach is key. So that's the reason we're looking at the process-driven approach. Why is it generally needed to take a look at the process-driven approach? For a company, three parts are essential: the product, the service, and the internal processes. Products are freely available or information to the product at the internet. They're comparable, and through re-engineering, you can't differentiate your company from the customer in the long run. Also services like system integration, the result is clear. Everybody offers the same service, and even if people don't know the service, they won't buy it. So you want that people know products and services. So therefore, they are widely communicated through advertising, and the information about them is easily accessible. On the other hand, processes are internal knowledge. They are not communicated. It's also one huge problem within the Robotop research project. They are not freely available, and so you can differentiate from your competition. Therefore, process-driven approaches are key, especially in microservice architectures. With them, you can differentiate from your competition on the long run, cheaper and more efficient, and get better results. Looking at the engineering processes, there are different phases. If you want to automate these phases, there are different roles who are involved. On the one hand side, the domain expert is involved, who knows the processes, who develops the processes. On the other hand side, there is the IT department who hard codes it and makes it executable. Generally, there are two aims within processes. One is for documentation and development of processes. So there are UML, ARIS, EPC, different tools just for the reason that you can communicate, that these processes are transparent and that these processes are available. On the other hand side, there are tools like Excel with VBA or other platform tools who make this process runnable. So you can execute these processes, so you can use processes and don't have a person to think about these processes before you can get them running. The biggest problem within is if you have two tools, you have a manual synchronization problem. That means in most cases, documentation and process execution is developed in parallel. This leads to the problem that you have to synchronize. This is an overhead and it's mostly not done. Huge problems arise out of this situation. To make it more explicit, you have 4 process goals: documentation, analyzing and optimization, implementation, and execution and monitoring. Therefore, different roles are available. The business expert, who is the key person who knows the processes, the business analyst, who improves, understands, and enhances the processes, and the computer scientist who hard codes the processes within the IT landscape. And lastly, the software who executes and monitors it. There are 2 perspectives. Before the introduction of BPMN, before different tools were used, and so a lot of coordination effort is necessary because different tools lead to higher mediation effort. On the other hand side, after BPMN, you can use this language, which is standardized in a norm, and also give this language directly to a process engine, which is able to execute these processes. Therefore, you have one line, no break in communication, and therefore everyone is working on the same tool, on the same environment. How does a general architecture look like? On the one hand side, you have a BPMN process model, which is modeled via standardized tools like Camunda or Signavio. Then these process models are given to a process engine, and you normally automatically synchronize these tools. And out of these, the process engine has a task list. It executes the processes and handles the whole stuff. Though, when you put these executable process models in a process engine, there's on the one hand side task allocation, automatic service calls, automatic decisions, and this is all done through the process engine. A lot of service orchestration, which can also be used for microservices, the monitoring and reporting part, so you're just informed when you have to do something, and also the workflow management from one person to another. And the participants within are just connected to the systems and are informed when there is an action needed. The general PDA architecture consists of 3 basic layers. The process application layer, which has the pure business processes, the service contract implementation layer, which connects the business processes to a real IT environment, and the backend layer where the concrete real IT tools are available. And to enhance this, we have the front-end shell. The front-end shell is more the communication, so you can connect every tool via REST API to the PDA, use this process-driven approach within every application which has REST API or other comparable interfaces. As an example, you can at first have a small business process. The small business process coordinates an engineering process. This business process has then to connect to different services, and these different services are called via the service contract and implementation layer. So if some service in the backend is changing, then you just change the service contract and implementation layer and not the whole front end layer or the process-driven application layer. So this makes the whole approach somehow independent of specific tools, which is very useful. And within you can have a stateful communication, a stateless communication, and therefore the integration layer serves also as a buffer if you have to wait for something or something has to be accumulated or stuff like that. Within our demo example, we implemented the PDA architecture within an easy engineering use case. This easy engineering use case was for simplification reason very small, but it highlights the possibility and the usability. So we take a risk assessment process. On the one hand side, some manager triggers a process and the employee has to do, so the engineer has to do a risk assessment. Then this whole SCL layer connects to different tools. So in our case, what's common in engineering, we have a Excel tool. This Excel tool has very specific engineering knowledge and is hard to rebuild. You can call the Excel via REST API call with the VBA programming language. And then you can connect these processes to different statistics services, email services, database services. It was very useful to integrate engineering tools in the whole scope. Orchestration for management is a hard and difficult task. To sum it up, we introduced a minimal functional PDA architecture within engineering. So you have the BPMN and the DMN modeling. We have the user management, you have the task management and process execution and process monitoring, which is done within the process engine. And you can add additional components like specific user interfaces. You can communicate with external tools like email server, apps, or other stuff. You can use standardized data exchange through JSON. You can integrate logic within the process engine through Java. And you can also integrate engineering tools for communication. But in our use case, we started with the Excel tool integration because it's the default tool in many small and medium-sized companies. And therefore, especially Excel tool orchestration was a highly beneficial use case for our approach to start with. On later phases, you can integrate these functionalities of the Excel use case within a microservice. Take a step further, you can also use the PDA approach within our virtual reality application. So as I mentioned in my other talk on the CIRPe, you can do a lot of VR planning, VR configuration, and these processes have to be orchestrated. And to orchestrate these processes, PDA also fits very well. Thank you for your attention, and please don't hesitate to contact me. Follow me on ResearchGate, follow me on LinkedIn, so we can stay in touch for future research exchange. Finally, we would like to thank the BMWI for the funding of Robotop. Thereby, the research project Robotop is funded by the German Federal Ministry of Economic Affairs and Energy, BMWI. Robotop is part of the technology program PACE, Digitale Technologien für die Wirtschaft, and is guided by the Project Management Agency in Cologne. Thank you.